Welcome to my channel and welcome to Basic Concept of Chemistry. Here in this video I am going to discuss about solution and its strength and how to dilute them to a desired concentration. Every biologist should know about this because our result of the experiment depends on how accurately you prepare them and dilute them. Not only that, in some national level examination you are asked to dilute a solution to a desired concentration. So let's start the discussion. Solution is a liquid mixture in which the solute is fully dissolved and distributed uniformly within the solvent. You can prepare three types of solution. For example, you can dissolve one or more than one solid materials in water or other solvent like NaCl solution, or you can mix more than one liquids like hydrated ethanol, or you can dissolve gas in the liquid like dissolve oxygen in water. There are several ways by which you can express the strength of a solution. Here I have only discussed those methods that are widely used by the biologist. You can express the concentration of a solution qualitatively. For example, very concentrated solution or less concentrated solution. You can express the concentration of the solution quantitatively also. For example, 1 normal HCl and 5 normal HCl, 5 times more concentrated. These are the list of ways by which one can express the strength of a solution. Molarity is widely used to describe the strength of a solution. It is expressed as number of moles of solute in grams dissolved in 1 liter solution, and the unit of molarity is moles per liter. You can calculate the molarity of a solution with this equation if you know the weight of the solute and the final volume of the solution. Normality is generally used to describe the strength of an acid or base. It is expressed as the number of gram equivalent weight of the solute dissolved in 1 liter solvent. Molality is not so popular like molarity. It is generally expressed as the number of moles of solute per kg solvent. This is the equation. Formality is generally used for those chemicals that ionized in solution like NaCl, KCl, and formality is generally expressed as the formula weight in gram per liter solvent. Unit is same as molarity. This is the equation by which you can calculate the formality of a solution. Percentage can be expressed in different ways like weight by weight, weight by volume, volume by volume. You can also mix two liquids into different ratio. For example, 20 ml ethanol mixed with 10 ml water to get 2:1 mixture. To calculate the molar mass of a solute, you just add the atomic weight of the constituent atoms. You can find the atomic weight from the periodic table. Here I have calculated the molar mass of HCl, NaOH and glucose. To calculate the gram equivalent weight of an acid or base, just follow this rule. And I have calculated the gram equivalent weight of HCl and H2SO4. And finally, I have shown how to calculate the formula weight of a compound. Just add the atomic weight of the elements present in the compound. In the laboratory, you can prepare two types of solution. Working solution, that is prepared freshly, and directly you can use it in your experiment. But stock solutions generally more concentrated and can be stored longer period and reduce reagent preparation time, but it must be diluted before the experiment. You can dilute a solution directly using this equation, that is V1 into S1 is equal to V2 into S2. Or you can dilute a solution serially in this way as I have described in this picture. Solution number 1. You have to prepare 300 ml 0.5 molar H2SO4 solution from 18 molar H2SO4 stock solution. I have used V1S1 is equal to V2S2 formula. Here V1 is unknown because we don't know how much solution we need to prepare the working solution. S1 is 18 molar, V2 is 300 ml, S2 is 0.5 molar. So V1 is 8.33 ml. So add 8.33 ml 18 molar H2SO4 and mixed 291.67 ml water. In problem number 2, I have calculated the strength of the urea solution using V1S1 is equal to V2S2 formula. You can pause the video to watch how I solved this problem. In problem number 3, I have diluted a solution and the strength of the final solution is 10 to the power minus 3. But I have diluted it directly. You can also dilute it serially as I have described earlier in this video. If you like this video, don't forget to press the like button. You can share and don't forget to subscribe my channel, and thanks for watching.